Hello everyone, welcome to KripAcademy. So today we're going to be going over the rational root theorem and Descartes' rule of signs. So we have this polynomial here. It's a fifth degree polynomial, it's x to the fifth. And what we're going to want to find out using these two rules, theorems, whatever you want to call them, is how many positive roots can there be? Positive real roots can there be? How many negative real roots can there be? And how many imaginary roots can there be? And what are the possible zeros of this function? So, to start, we'll start with the rational root theorem. So, essentially what the rational root theorem says is that all possible rational roots for a function can be written as a factor of the constant. So the constant is 12, so factors of 12 are 1, 2, 3, 4, 6, and 12, and plus or minus all of these over a factor of the whatever a is, so whatever this number is. Now we know this is 1 because there's not anything there. So all of this can be over plus or minus 1 because the factors of 1 are 1 and negative 1. Really, you're not going to have to worry about this plus or minus. You could just write it as a fraction, and then every fraction can be plus or minus. So hypothetically, let's say that a was equal to 4. If a was equal to 4 here, then it would be any of these written over plus or minus 1, plus or minus 2, plus or minus 4, because that's the factors of 4. So what this tells us is that any of the zeros of this function can be written as plus or minus one of these numbers over plus or minus 1. So since I just told you that the plus or minus doesn't matter, since every single one of these is going to have a plus or minus in front of them, you can just kind of get rid of this and get rid of this and just do all of these down. So the possible rational roots for this function are plus or minus 1, because 1 over 1, plus or minus 2, because 2 over 1, plus or minus 3, because 3 over 1, plus or minus 4, because 4 over 1, plus or minus 6, because 6 over 1, and plus or minus 12, because 12 over 1. Now, chances are it is probably not going to be whatever the largest one is. It can be. I'm not saying it's completely out there, but chances are it's probably not going to be this one. So I wouldn't guess this one first. Because what you can really do with this is something called synthetic division, which means essentially you write all of the coefficients of this out and you divide, you essentially long divide by whatever this number is, but we're not going to go over that right now. So using the rational root theorem, we figured out that the zeros of this function have to be one of these numbers right here. Now the other thing is Descartes' rule of signs. So essentially what Descartes' rule of signs says is that the number of positive rational roots of any given function is equal to the number of sign changes in that function. So we know this is plus. So 1 doesn't change, so this is 1 change right here. Here it changes again, 2. Here it changes again, 3. Here it changes again, 4. it's equal to the number of sign changes or less than that down by 2's. So there can be 4 positive rational roots, or there can be 2 positive rational roots because 4 minus 2 is 2, or there could be 0 because 2 minus 2 is 0. So it's equal to the number of sign changes here. The number of negative roots according to this theorem, so the number of negative roots of negative rational roots, is equal to the number of sign changes if you were to plug in -1 for x. So if we plug in -1 for x, since this is an odd degree here, we know that this will change to a negative because if we plug in -1, it would be -1 to the 5th is -1 times -1, which is 1, times -1, which is -1, times -1 again, which is +1, times -1 is negative. So we know that this is now negative. Since this is even, we know that the sign doesn't change, so this is also negative. Since this is odd, we know the sign does change, so this is positive. Since this is even, the sign doesn't change, so this is positive. Since this is odd, we know that the sign does change, so this is positive. And this is just a constant, so we know that this stays the same, so this is positive. So when x equals -1, negative, negative, positive, there's one sign change. Positive, positive, positive. So there's only one sign change. So we know that there can only be one negative rational root for this function. And that is essentially what Descartes' rule of sign says. So if we were to make a table of all of the possible roots for this function, so we'll label this column P for positive, we'll call this column N for negative, and we'll call this column I for imaginary. Because remember, there can also be imaginary roots. So there can be 4 positive, there can be 2 positive, or there can be 0 positive. We know that there has to be 1 negative in all of these cases. And we know that because of the fundamental rule of algebra, that this degree is the number of roots that this guy has, including multiplicity. Which essentially what that says is that there can be 2 instances of -2 as a root. So there could be like x plus 2 squared would give you 2 -2's as a root. So we know that there has to be 5 total. So here there's 4 positive and 1 negative, which means that there can't be any because 4 plus 1 is already 5. Here there's 2 positive and 1 negative, which means that there has to be 2 imaginary. And that makes sense because of another theorem, which we haven't gone over yet, which is the conjugate theorem, which says that imaginary and irrational roots always have to come in pairs. So the number always has to be even. Or if there's 0 positive and 1 negative, that means that there's 4 irrational. Now, I'm not going to go over exactly how to factor this just yet. I'll probably do that in an upcoming video. But I will tell you that the factors of this are x minus 3, x plus 2, x minus 2, and x squared plus 1. Now with all of these, from this one we know that one of the zeros is 3. From this one we know one of the zeros is -2. From this one we know that one of the zeros is +2. And this will give us a 2 irrational roots, excuse me. So if we were to set this equal to 0, that would mean x squared plus 1 equals 0. Or, I'm going to go up here now, x squared equals negative 1. Square root both sides, so you get x on this side equals plus or minus the square root of negative 1, which is just I. So x equals plus or minus I. So those are your other roots, plus or minus I. So we have two positive roots, 3 and 2. We have one negative root, which is negative 2. And then we have two imaginary roots, which means that this is the function that we have here. 2 positive, 1 negative, 2 imaginary. So that checks out. Now, these are the possible rational roots that it can be, according to the rational root theorem. So it could be 3. Bam, right there, we got that. It could be negative 2. Bam, right there, we got that. And it could be positive 2. Bam, right there, we got that. So this checks out as well. So that is essentially what the rational root theorem and Descartes' rule sign says. Thanks for watching.